Hey everybody, and welcome back to another episode in Software Engineering and Salesforce. My name is Brooks Johnson, and today we're talking about the frequency counter pattern. I think this is going to be a good one. I've been meaning to make a few videos on problem-solving patterns in Apex for a while. And I want to start with the frequency counter because I think it is just the most useful day to day, useful in your work, useful in job interviews, and I think solves some of I'm going to call it like the least performant code that I feel like I see pretty regularly in Apex code bases. So stick around to the end. I think this is going to be a good one, and hopefully you'll take away something that will, if you're not familiar with this one already, make you a better programmer, make you a better software engineer, make your boss, make your clients, make everybody a little bit happier. All right, so the frequency counter pattern, and I want to be clear, right? When I talk about these patterns, these are not design patterns. You won't find them in, do I even have the book, right? Yeah, over here. You're not going to find them in here, right? Those are design patterns. These are problem-solving patterns, and there's a few you're going to see a lot. I'm what I call frequency counter, and I took that name from, I think, a Colt Steele Udemy video. If you're on Leak Code or something, a lot of times you'll see this just referred to as hashing, because hashing is what we're using to solve it. Then there's also things like the sliding window, two-pointer, and I think we'll do videos in all of them. But frequency counter and hashing, to me, is just the most fundamentally useful and solves some of the most common problems I see pop up in Apex. So with that, when we're talking about the code, and right now you can see I have a test class set up here. And I guess I'll just explain, here's the problem we're trying to solve. So let's say I'm going to give this in a job interview. All right, here's our example, right? We've got some sort of a collection, right? In this case, it's a collection of strings, right? Some words. Hello world, dog, cat, taco, dog, cat, dog. And what I would like the candidate to do is write me an algorithm that finds which value in that list of strings is repeated the most often, and how often is it repeated, right? So this should return, right? It's going to return a map, right, of string and integer. So what I expect to get back, right, is a map with one key value pair, in this case, dog 3, right? The key of dog was repeated 3 times. And just for so my assumptions, if I was interviewing somebody, that there's always going to be a winner, right? I'm going to say that we don't have to worry about ties. There's always going to be a clear winner that is duplicated and duplicated more often than everybody else. So you're going to Brooks, why do you ask this? I'm going to tell you why I ask frequency counter questions. And I like to say this, I think it's even in my LinkedIn profile. I always say, and this is from Bob Martin, it's not enough that the code works. These types of questions are not only can you solve the problem, but can you solve it with scalable, efficient code? And this is where I say, to me, this is the value of having candidates whiteboard. And I don't think it's even happened to me often enough in my times interviewing in Salesforce. Typically, it's more behavioral, and I'll get a few questions, right? I don't know, what are some, when would you use, queuable Apex or something? Tell me about a hard problem you solved. The problem with those is they don't really show that the candidate actually can really not just solve the problem, but really solve it. I'm going to call it a clean, maintainable, and efficient way. And the fact that our code is efficient is important, right? Not only I was dealing with Salesforce governor limits, but I would say nobody ever bought a computer. Nobody bought Salesforce so their business could run more slowly. So it's on us as the programmers, as the software engineers working on this platform to write the most efficient code we can. So we have our problem. Now I'm going to switch over to, I got my class here, frequency counter, all right? And, right, public static, it's going to return, its return value is a map, string integer, and it's going to take a list of strings, right? So that's our basic problem. The reason I ask this, and I'm going to say, so let's just talk about if you got this in an interview, the first thing, and I think the first thing that comes to mind is you could totally, you know, I'm going to call it like the brute force solution or the naive solution is going to be a nested for loop, right? We could do something like, you know, I don't know, you know, how are we going to help me, right? 4 strings dot on, then, you know, I don't know, we could do, you know, for int j, you know, equals. But you say, like, we'd go through the first time, we'd get the first string, then we would iterate through the whole set of strings a second time, the whole list of strings a second time. Hey, you know, what else do we find that matches? We would update a count, and this would work. This would solve the problem. I'm going to get rid of this, though. But the problem is, so this is a nested for loop. And as a programmer, a nested for loop should set off all of your code smell spidey senses. As soon as you see that, you should like, this is not, you should start looking for a different way to solve that problem. And the reason is nested for loops run in quadratic time. If you are not familiar with Big O, if you're not familiar with, say, quadratic time, linear time, constant time, check out, I did a video earlier on, say, like bubble sort and quadratic time. Check that one out. These are important concepts because if you're interviewing, first thing is if you can only come up with a brute force solution, first of all, that's better than no solution. So go for it. But what I would expect a candidate to do, even if they're the only way they can solve this problem is with a nested for loop, one, I would expect you to be able to articulate to me why that's not good. All right. So, and I said, like, I've been there, like, hey, all I can come up with is a brute force solution. So at least be able to explain to the interviewer why I think this is what I've got, but this is also why I know it's not optimal, to show that I at least do understand that. So anytime you see a nested for loop, that means our code's going to run in quadratic time. And that means, right, if we had 10 inputs, right, it means it's going to need up, you know, 100 steps, right? But if we double it to 20, right, it's squaring each time. So it's not just doubling the number of steps, it is squaring the number of steps. So we start to have the runtime of our algorithms grow really, really quickly. And I always say, like, almost any time I have seen CPU governor limits happen in Apex, I find nested for loops somewhere down at the bottom of it. So what we want to do is come up with a different solution. And the solution I call the frequency counter pattern. As I mentioned earlier on Leak Code, you'll see it's sometimes called hashing because we're going to use a map. And maps, anytime you see any sort of a question or any problem, and I guess I'm kind of doing this video from maybe more of a job interview point of view, but this is a useful everyday pattern. So you need a count of something, and especially you need a count or you need to compare the values in one collection to the values in another collection. You should always, your first thought should go to a map and what I'm going to call hashing, because maps, right, in Apex, it's a map. In Java, you know, you have a hash map, in Python, a dictionary, but they all use hashing to some extent to give us so the power of a map as a data structure is constant time, retrieval, and insertion. So if I go to my map and I say, hey, you know what, if I have a map of prices, right, and I have, you know, key Apple, right, map to price, you know, $1.99 a pound, right? When I go to my map and I say, you know, get me the price for Apple, it's not iterating through everything, right? This isn't a linear time thing where I'm going to iterate through every single key. It is constant time, right? It goes to the key Apple, returns the price. So maps are really, really powerful data structures for all of these kinds of problems. And it's really important that you understand that as a data structure, maps give us this constant time insertion and retrieval power. And maybe I've thought about maybe in a future video, we'll just build our own map. Build a map from scratch in Apex, just to kind of show like, this is how it works. This is why, you know, it gives us that constant time operations. But for today, we're not building our own map. We are just going to solve this problem. So what I said, we've got our count duplicates. So first thing I'm going to do is I got to solve this problem, is I need a map, right? I'm going to a map of string to integer. And I'm going to call this count by words. And that's going to equal a new map string integer. All right. So we've got our first step in any problem was create a map, right, to store our values. Now what we're going to do, we're going to iterate over all of the values that came through in our strings, in our list of strings. And we are going to go into our map. And if it contains that value, right, we are going to update. So if in our, in fact, let me grab this from our, I'm going to put this in our comments so we have it to see. All right. All right. Right. So if map contains cat, right, we are going to update the value to, to 2, right? If it does not contain the key, like hello, sees hello for the first time, it's going to, give the map the key of hello and the value of 1. We found at one time. So this is how we're going to start with this problem. All right, so let's just do for string word in strings. All right, and we're going to say if, what do we call that? Count by words contains keyword, right? So if it already has that key, right, we know, so that means we know we've already seen this value. We've already seen this value. So now we're going to increment the count to by +1. So we're going to say count by words dot put. I'm going to say word. And then, so if you've never incremented a map in Apex, this is, how you have to do it. It's a little clunky. I wish we had like the Java getter default, but we do not. And then, so that, remember, so this is our condition. If our map already contains that key, we are going to increment its value by 1. Else, we need to give the map that key with a value of 1. So I'm going to say count by words. Sometimes my code completion gets in my way. Count by words dot put. And we're going to do word 1. All right. So remember, if we've not seen that word before, we're going to go to the map and the word is going to be the key and the value is 1. If we're iterating over and we're like, because remember, maps are constant time. We're like, hey, map, you got a value for, so first time through, right? It's going to have world value, hello, value 1. World value 1. Dog value 1. Cat value 1. Taco value 1. And it's going to get to dog. And remember, here's the thing. Maps are constant time, right? So each time I'm going, hey, map, right? Like we're going to go into this condition, right? It contains the key. But where the map structure, and this is where it's so powerful, it does not have to iterate over all its values, right? To say like, do I already have so this is not a linear time operation. It's not iterating over all of these to say, do I contain a key for dog? That is constant time. It's saying, boom, yes, I do. So then we are just going to update the value. So now we've built our initial map. We've got our values, all right? Now, our next challenge for this problem is we've got to get this data out and return it back in a way that we need, right? So we've got every single word and we've got it mapped by how often it occurs. But now we need to go figure out what is the most frequent and return that. So what I'm going to do is I'm just going to declare a string here. String. And I'm going to call this the global string. And I'm going to set it equal to just an empty string, I guess. And I'm going to do another one. Not a string, an integer. Integer. Global max. And I'm going to set that equal to 1. All right. because we know just based on the conditions of our problem that we're going to have values with a minimum. So we're looking for something greater than 1. So that was just kind of given the conditions of our problem, which is why we can do it this way and not worry about set for 0 or anything like that. Now what we need to do is we're going to iterate over the values in our key set. I'm going to say for string stir in count by words dot key set. All right. And I want to call it, because I know probably if you're astute, you're saying, hey, that's a second for loop. And earlier in this video, you totally trashed a nested for loop. So what I'm calling like for loops, separate for loops are far, far more efficient than nested for loops. So if we have this for loop and down here, then this is the whole key. They are not nested, right? Instead of squaring the number of steps it takes, it's going to double. So what that means is if we passed in 10 words, right? So then we had to iterate over, n steps 10 times down here. And we'd say roughly the same down here, n steps. So if for big O, that's now a question of a coefficient. So really it's like, it would be, instead of, it would be 2n. But when we're doing, big O, we can usually just drop coefficients. So this still remains a O of n, a linear time solution that it grows with the number of inputs. So, if this list went from 10 values to 100 values, right? It's O of n, right? That's still how many steps it takes to solve versus squaring every time. So that's really important to take away from this. We could have 2, 3 for loops in here, and it's still much, much more efficient than one nested for loop, okay? So now we're going to iterate over our key set, and I'm just going to say, global string equals string, all right? And I'm going to say, what we need to do, we need to add an if condition in here. So I'm going to say if count by words dot stir is greater than global max, right? So, hey, the value with that key, is it greater than global max? So basically now we're like, is it bigger than 1? If so, we're going to reset the global string value to that, and we are going to set our global max is going to be equal to count by words dot get stir. Probably come up with a better name for that than stir. So we're saying, if it is, so we're going to iterate through for each value in the key set, right? If its value is greater than the current value of global max. So when we get to, something it's I'm trying to think of when we get to, where do we get to? Our second value of dog, right? It's going to say, hey, are you greater than 1? Yes. If so, now go ahead and reset global max to 2 and make global string equal to dog. All right. Then all we have to do now is go down here. We should have this all put together. I'm going to get rid of these empty lines. Return. And we are just going to new map string integer. And we are just going to map global string, not a period, global string to global max. All right. And if you've never seen this syntax before, this is just a map constructor in Apex. So rather than, write, map with new map and then, map.put, I can just call the map constructor and I can say, hey, the value of global string, and I use this fat arrow, right? It's the only place in Apex you use the fat arrow, like, a JavaScript arrow function, maps to global max. Now, with some luck, this will compile. And then we can run our tests and see if it passes. Nice, it passed. And just to double check all our logic, so hello world, dog, cat, taco. Let's add another taco right here. Recompile. And the reason I did that, as I thought through this, is like, I've kind of had this set up so dog is always going to be constantly, the global max, right? So let's do something where we know, hey, taco is actually going to be the global max here for a little bit, but then it should switch over to dog. Let's make sure it solves that. Because I'd hate to make this video, put it on GitHub and find out I missed something stupid. Let's run it. Perfect. It passed. All right. That is the frequency counter pattern. So remember, nested for loops, almost always bad. They run in quadratic time. When you have a solution or you see a problem that you could solve with a nested for loop, there is almost always a better solution for it that involves a map. Because remember, maps give us constant time, insertion, and retrieval into that data structure. So that let us go from a solution that ran in quadratic time to a solution that ran in linear time. And now you did not blow up your org because you burned through your CPU time limits, and your boss and your client and all your stakeholders love you. So hopefully that was useful. If it would, please take a second and love it. Give it a thumbs up. Seriously, hit the thumbs up button and give me a like and a subscribe, and tell your friends if this was useful. I guess maybe it wasn't. Maybe you'll think it was garbage. I don't know, but it was good to get in here and make a video. So I'll talk to everybody in the next one. Take care.